Welcome to the next session. Today we are going to discuss about manometers. So as we have seen the last time during our lecture of center of pressure and total pressure, we found that a column of water exerts the pressure on the bottom, and that pressure can be calculated with this formula: P is equal to WH. Right? And then we went for total pressure when we multiply this pressure by area. But now in this session we will be concentrating on the pressure. So this particular concept tells us that the height of water column can be used as a measure of pressure. So in this example, as it can be shown, that if it is the water H2O, right, then pressure acting on the bottom of this plate by this much water column is equal to W into H. Suppose instead of H2O it is oil of specific gravity 0.8, then naturally as oil is lighter it will exert less force on this area and hence less pressure. But height is same again here, height is same, H. So in this case P will be equal to W1H, where W1 is the specific weight of oil and which can be given as W1 is equal to S into W. W is specific weight of water. When we multiply the specific weight of water with specific gravity, here in this case 0.8, then this is the specific weight of oil, and in turn this value will be lesser than this value. So we must mention the liquid that we are using for pressure measurement. So if the value of H is say 1 meter, then pressure can be expressed as, in terms of height, as 1 meter of water. Or in the next case, we have replaced the water by oil. In that case, we will express it as 1 meter of oil. And both are not equal. This will be higher and this will be lower pressure. That's why we must take into consideration the effect of specific gravity. So we are now going to see a simple concept of manometer. The first manometer is piezometer. Now consider this is a cross section of a pipe which is carrying some fluid under high pressure, and we want to measure the pressure. So what we will do, we will just insert a vertical transparent tube like this. So due to pressure of the liquid flowing through this pipe, it will flow up. So say it flows up to this height. Now the rise of water in this tube, transparent tube, is due to pressure. And so again we can use that formula, P is equal to WH, and if we measure this height, it is H, and we put it in this formula. If it is H2O, then we will put W into H. So put this height here, you will get pressure. Or of course this its unit will be Newton per meter square. Or otherwise we will express pressure in terms of H meter of water. Or in another pipe, oil is flowing and the height is H1, so H1 meter of oil. Like this, or suppose mercury is there and the displacement of mercury is say 0.2, so 0.2 meter of H. So this is how we can make use of a simple simple transparent tube which is to be inserted into the pipe, and the liquid will flow into the pipe to certain height. Measure that height, put into this formula, you will get pressure in this term, or otherwise you can express pressure in terms of meter of that liquid column. So this is the simplest principle of piezometer, P-I-E-Z-O, piezometer. So pressure is measured by balancing the liquid column. What is the advantage of this piezometer? That it is simple, just you have to insert a tube. However, you cannot measure high pressure. High pressure cannot be measured because if pressure is high, then this height will be more and you will have to use very high displacement will be there. So long length tube is to be measured, which makes taking reading practically difficult. So you cannot measure high pressure. Similarly, you cannot measure negative pressure, means less than atmospheric pressure. Why? Because here pressure is higher than atmospheric, that's why liquid is going up into the glass tube. In the other case, when there is negative pressure inside the pipe, the surrounding air will come into the pipe, which is not allowable. That's why in this particular situation, in this particular arrangement, you cannot use this arrangement for negative pressure measurement. So for small pressure measurement, this is very simplest idea to use the pressure. Now we will see one more concept of height of water column or height of liquid column, and we will change the nature of liquid. Here only just note that you have to take height from center of the pipe. So this is that height. Okay. Now let us see this particular situation, that there are different pipes like this, which consist of different liquid. Right? It consists of different liquid. Say here height is H1, another liquid, here height is H2, another liquid, and here the height is H3. Now these heights are adjusted in such a way that the pressure here, suppose the pressure here is P1, here it is P2, and here it is P3. So pressure in all the column is equal. This is how we have adjusted the heights. So P1 is equal to P2 is equal to P3. Right? Suppose specific gravity of this particular liquid is S1. Of this liquid is S2. And of this liquid is S3. So we can write P1 is equal to W H1 is equal to W H2 is equal to W H3. W, actually this is liquid 1, so we should write W1 H1, W2 H2 and W3 H3. So specific weight of that liquid into height of that liquid. Now if we add one more column here, and now we want to fill this column by water, and then my question is, how much should be the height of this column, water column, so that again pressure here is same as in the other cases, is equal to P4. So again here in this case it is W into H4. W is specific weight of water. This is H2O. Now I can replace W1 by S1W. So W1 is equal to specific gravity of this liquid into W. So S1W H1 is equal to W2 by S2 W H2, S3 W H3 is equal to W H4. Specific gravity of water is 1. Now you can see here W is common everywhere, so you can cancel it out. And so becomes the formula S1H1 is equal to S2H2 is equal to S3H3 is equal to H4. Now all these terms are in meter of water. You can see S1H1, S2H2, S3H2, H4. H4 is meter of water. So all these things comes in meter of water. So this is how you can convert one height of a specific liquid into height of another liquid, into height of one more liquid. So these things are interchangeable. You have to use specific gravity of that particular height. So we are going to make use of this equation in our next application, and that is U2 manometer. So we have seen that piezometer is a simple and very useful manometer, but with the help of piezometer you cannot measure moderate to high pressures, because then the displacement will become very high and becomes practically difficult to measure. So what we will do, see, we have seen this formula P is equal to WH. So if we want to reduce the height, then W should be more. Means that liquid should be of high specific weight. But of course we cannot, suppose I want to measure pressure of oil. How can I increase its specific weight? That is not possible. So what I can do, I can make use of a manometric fluid which is having this quality, that is high specific weight, which is nothing but mercury. So see here, its construction is like a U shape. So it is called as U-tube manometer. This U-tube is filled with mercury. So when both the ends are open, then the mercury level in both the limb, this is left limb, and this is right limb. So level of mercury in both the limb will be same. Now what I do, that here is a pipeline. So I attach this one end of the U2 manometer to the pipe, through which some liquid is flowing. Now what will happen, this liquid will try to exert some pressure on the manometric fluid. So it will try to push, if pressure is high, then it will try to push the mercury in downward direction. Let us say the new mercury level becomes this. So this much mercury will be lifted in this direction. Now see, here you get deflection in the level of mercury in left and right limb. Why this deflection is there? Due to this pressure. So you can make use of, you can measure this deflection, and with proper formula, with the help of this deflection, you can express it in terms of the pressure of liquid acting over here. Let us say the pressure of this system, this is system A. So pressure is P. But I want to express it in terms of height of liquid column. So I have used this formula. P is equal to WH. Now I want this formula in terms of height. So I will divide it by W. Right? So PA is equal to W by H. Okay. Now this is the pressure here. Sorry. PA I want to express in terms of meter, so I would like to make PA by W, which is H. So this is how I will express the pressure here in terms of head. Of course, the unit is meter of water. Why? Because we have divided it by W, which stands for specific weight of water. Okay, so pressure here is PA by W. As you go in horizontal direction, pressure remains same. But as you go down, now see, you are going down by this much height. Let us say this is H1. So as you are going down and you come here, so here you have an additional column of liquid of specific gravity, say S1 by height H1, of height H1. So as you will go down, the pressure intensity will definitely increase. So pressure at this point will be equal to, I will write it here, so PA by W is pressure acting at this level. If you go down by height H1, then pressure will increase by this much height. But see here, the unit is in meter of water. Here H1 is the unit in terms of meter of this liquid. So I want to convert it into meter of water. We have seen this formula. So I will add PA by W plus S1 H1. H1 is the height of this particular liquid. When you multiply it by its specific gravity, it is converted into height of water column. So this is also meter of water, this is also meter of water. So you come here. Again at horizontal level, the pressure remains same. There is no change. Now you are going up. You are going up by another height H2. So as you are going up, the height of liquid level is decreasing. So pressure will also decrease. So I will write here minus. Now see, H2 is the height by which you are going up, but that is of mercury. This is Hg, mercury. So you are going up by H2 meter of Hg. Now you want to convert it into meter of water. So instead of only writing H2, you will write S2H2, where S2 is the specific gravity of mercury, which is 13.6. So now you come here. Now you can see this end is open to atmosphere. So the pressure acting over here is atmospheric pressure. And we do all the calculations with reference to atmospheric pressure. So for that purpose, we can consider it as 0. That's why here I have come to this particular point and gauge pressure acting over here is 0. So I will equate it to 0. So pressure here in terms of head is PA by W. As you go down, pressure increases. So you add S1 H1. You go up, pressure reduces. So minus S2 H2. And here pressure acting is atmospheric, which is 0. So now the formula becomes PA by W is equal to, this will go to right side, it becomes S2H2 minus S1H2. Now what is the advantage of using U-tube manometer? You are making use of mercury, which is very dense. So you are making use of high specific weight liquid, and that's why you can measure high pressure over here. Because even if pressure is very high, the deflection here will be comparatively lesser, as can be seen in piezometer. Because there the liquid itself goes up. So if pressure is high and liquid is lighter, its displacement will be much more. Now here you are using mercury. So even if the pressure of which the pressure of liquid you want to measure is a lighter liquid and pressure is higher, still you are ultimately exerting that high pressure on high density fluid, so which comparatively reduces the deflection. So if you can measure this deflection with this formula, you can find out PA by W and ultimately PA. The answer of this particular expression will be in terms of meter of water, and when you will multiply it with W, that is specific weight of water, it will be in terms of Newton per meter square. So this is how U-tube manometer can be used for measurement of medium to high pressure. So this is the advantage of U-tube manometer. Another thing, you can measure negative pressure also. Suppose pressure here is lesser than atmospheric pressure. So atmosphere pressure will now exert the pressure on the right limb, liquid level on the right limb. And as it is higher than the pressure here, the mercury level will go down here and will go up here. So this is the new mercury level. Suppose this is H2. Now see how the formula changes. Again, pressure here in terms of height is PA by W, meter of water. We are going down by H1 height, so plus S1 H1. Again we are going down by H2 height, but this is of mercury, that's why the equivalent height will be H2 H2. So now you are here, the pressure at the horizontal level is same. So here it is atmospheric pressure, which is 0. So you can equate it to 0. And now PA by W becomes minus S2H2 minus S1H1. So after putting the value, you will surely get some number here having the negative sign. This negative sign indicates that the pressure is lesser than atmospheric pressure. So no problem here, even negative pressure can also be measured. So whatever was the limitations of piezometer, all those limitations are overcome in this U-tube manometer. So this is how U-tube manometer can be used for measurement of pressure. Both these types of manometer are of simple manometer, which gives individual value at a particular location. Sometimes we are interested in the differential value, difference between the pressure at two different locations. So you can convert the U-tube manometer into differential manometer. So what we will do here, I will attach this end to another system, another pipe. This may be the same pipeline at different location, or you are having two different pipeline, and in between those two pipeline we have struck a U-tube manometer. Whatever may be the case. Let us say the fluid here is different. Let us say it is B, fluid system B, and specific gravity of this liquid is S3. Right? Now I will continue with this only, and the level of this liquid here is up to this. Is up to this, right? And say this particular height is H3. So again we can follow the same principle. The pressure here in terms of meter of water or height of liquid column is PA by W. You are going horizontally, so pressure here is also same. You are going down by H1 height of liquid S1 specific gravity. So pressure here becomes PA by W plus S1H1. Again going down by this much height H2 of another liquid, because here there is a change in liquid. So as you are going down, so again it becomes S2H2. Now From this particular point, I am going up by height h3 of liquid of specific gravity s3. So going up, so pressure will reduce, so I will subtract. So minus s3 h3. So I will come here. Here means here. And the pressure at this particular point is, so this can be now equated with pressure here. Now this end is not open to atmosphere. So we will not equate it to 0. Rather, we will equate it to PB by W. PB by W. Again, this is in terms of meter of water. So all these terms are in meter of water. So we can add or subtract them. Their unit is same. So now this becomes the formula. And now we want to calculate the difference between these two systems. So what I will do, PA by W, so I will bring this PB here, PB by W, and all these things I will take on the right side, is equal to, so this minus will become plus, S3H3, this will become minus, minus S2H2, and minus SNH. So now here you just want to know the specific gravities of that liquid and their corresponding heights. You can put those values here and you can directly find out the answer in terms of meter of water here. Suppose your specific gravity S1 is 0.8, this is mercury, so 13.6, and this is another liquid of say 0.7. Right? So here you can see S3 means 0.7 into H3. Now you should have the value of this H3 height here. So 0.7 H3 minus 13.6 H2 minus 0.8 H1 is the difference in between these two systems. If you put the value of heights here, after you will do it practically, you will measure this height and you will put it in this formula. So either it will be a plus value or minus value. So if it is plus, it means that PA is greater than PB, and that's why the difference is plus. If it is minus, it means that PB is more than P. So this is how you can make use of differential U2 manometer to find out the difference. Here we are, differential U2 manometer. Again, here center lines are matching, but it is not necessary. Center line can be different also. So I can modify that thing here. So let us say this is how the figure is. And this is H3. So again, formula will remain the same. So that doesn't matter. So directly you will get PA by W minus PB by W. Differential U2 manometer.